Hello everyone, today we're going to talk about forces at an angle. Okay, so this is a physics video. So what we have, for example, we have a couple examples here. So the first one is an inclined plane. So if you have an inclined plane and you have an object that is sitting on the top of it, you're going to have angled forces. Okay, so if you've seen here, so what are the angled forces? You know that your gravity is always pulling down. Okay, gravity is pulling down. The second thing is your Fn, right? So that's your normal force from the surface of the ladder that is pushing against the object at a 90 degree. Also, you may have something called friction. So you may have friction. Okay, otherwise it's going to accelerate all the way down because you have an f of x component. Okay, so if we analyze this a bit further, you're gonna get this down right here. That is your FGY, and that is gonna be your FGX. Okay, so these are the components that of forces that are acting on that object. Okay, so for example, sometimes you may have an external forces that could change the forces acting here. So for example, if someone is applying a force this direction, okay, applying a force at this direction, at this point on the object, so that's the applied force. Well, if it's pulling this direction, the first thing is going to change is the friction. Okay, is the friction. Or let's say so it depends on the scenario. Okay, the friction depends on where the object is moving. Okay, so let's say that the object is moving this direction. Okay, so this direction being positive and the down being negative. So what's going to happen here is it depends on the applied force. So if, for example, the object is going downwards, then the friction is going to be upwards. Okay, and that depends. So for example, being here, now this is an angled force. Why? Because your Fa, it's acting on the central mass, so it's going on this direction. Okay, so again, you can delete this here. So with this, you have both you've got your x component, so that is Fax, and you've got your y component, that is your Fay. Okay, and that is the Fa. Okay, so then you could analyze those forces and answer whatever question you have that you want to answer. So on the x direction, you have a couple of forces. You have your Ff, you have your Fgx, you have your Fax. On the y direction, well, you have another forces. You have your Fn, you have your Fgy, and you have your Fay. Okay, so these two are part of the Fa, and these two are part of the Fg. Okay, so that is one example. Another example could be suspended objects. So suspended objects, for example, let's say you have that here, and let's say you have that's a wall, and you have a sign that's being hung like that. Okay, so that's a sign. So these are forces. And now, of course, when you say angled forces, it's very important to analyze the angles. Okay, so here you have this angle right here, that's theta, which is equal to this theta, and then you have here maybe another theta, or maybe that's same theta. All of these play into account when identifying angled forces, because you need to know your components. Okay, second thing here also, you may have theta given the question here. So this could be different than phi, which could be here. Okay, and then you could answer those questions because you could use the Z rule, and this could be angle force right here. This one, this could be your phi going this direction. Okay, so also you have to analyze your forces that are acting on this object. The first thing is your Fg going down. You've got your at an angle. Well, see, sometimes you could draw on the drawing, or you could just make one. So just simple box here. So you've got your Fg going down. You've got here tension 1, I'll call it. So that's T1. And you've got at a different angle, you've got your T2. Okay, so this here could be the theta, and this here could be phi. Okay, and you could use this to answer any question that you have. Okay, the last scenario that we have is just the completely basic one, is that you're just pulling or pushing at an angle. Okay, so for example, you have this object sitting like that, so you're either pulling, so you're applying force, or you are either pushing, which is the same thing, but you're pushing on the other side. The difference here is where you're going to contribute your forces. So for example, so here, let's analyze the forces acting on the pulling. So that's pulling, that is pushing. Okay, or maybe we could move this a bit further since it's stuck here. Okay, so what we can do here is that we could analyze the forces. Okay, so for example, your FG is going down, so that's FG. Up, you're gonna have your Fn, but notice they also remember that when you draw an arrow that represents the magnitude, okay, of the force. So I may draw a small Fn here, okay, and I may draw an FF going this direction, or a bigger FF, okay, and you're gonna know why I did this for in a sec. Also here I have another forces, so I could extend this FA, okay, and pull it down like this. That could be our FA going this direction, or we could use a different color here just to illustrate it's the same thing. So that's your FA, same magnitude. Okay, the second thing you have maybe your FG, okay, or your FG is going smaller. You have a bigger Fn, and then you're gonna have, let's say, let's say you're gonna have the same FF. Okay, so what's the difference between those two? Well, first you have to analyze your angle. So let's say that's your angle where you're pulling it from, okay, and that is your angle where you're pushing it from. The first thing you're gonna notice here is the difference in the Fn, and also the Fg and the Fg. The magnitudes are different. Okay, so in the first one, when you are pulling, you are helping the Fn from getting those from getting this weight. Why? Because you have an external Fa y that is going upwards. Okay, on the second one, you are helping the Fg. Why? Because you have here an Fa y going downwards. Okay, so this is different. So this is, let's say that's negative, that is positive. So these are different. So when you have more of a force, you need less of the other one to help it, right? To overcome the other force. So here you're helping the Fn, so you need less Fn, but you need a lot more Fg in order to compensate for those two forces. Same thing happening here. So you have less Fg because you have an Fay, so you need more Fn to compensate for those forces. Okay, so I hope this helped. That's just a quick video. Hope that helps in identifying forces at an angle. Thank you so much and have a good day.